Last week we talked about the difference between an integral that has no bounds, such as x squared plus 2x, and when we took the integral of that, we should get 1/3 x cubed plus x squared plus c. So we talked about the need to have a constant c, whereas also we compared that last week to something where we did have bounds. And if we look at this same function and we integrate, we would not include the plus c, and we would just evaluate from 0 to 2. So I told you last week that I would tell you what the c meant, or actually how to achieve the c, how to get the c value. So here we go. Today's the day. All right, so what's going to happen is you may see a question where, for example, they'll give you something like this. Now remember, that stands for the second derivative. So they're going to give you, let's say, the second derivative is 2 minus 6x. And then they're going to give you a set of conditions. So they may tell you, let's see, let's not use that. Okay, so they may give you y prime of 0 is equal to 4. And they may also give you y of 0 is equal to 1. So let's start with that. All right, so obviously if you have an equation of the second derivative, and then we have conditions involving the first derivative and the original function, then obviously we need to integrate here. So if we start by integrating the 2 minus 6x, okay, we're just going to do this the way we were doing last week. So we're going to get 2x minus 3x squared plus c. Okay. Now again, plus c because we don't have bounds. Now what we've technically found is the first derivative, because remember again that we integrated the second derivative. So when we integrate the second derivative, that will give us our first derivative. I'm going to write it as y prime. You could also write it as dy dx. Now the reason why I'm writing it as y prime, because what we're going to do is we're going to look at this set of conditions right here that they gave us about y prime, and that is what's going to help us find your c value. So you notice they say that y prime of 0, in other words, in your y prime equation, you're going to plug in x equals 0, and you're going to set it equal to 4. So I'm going to do 2 times 0 minus 3 times 0 squared plus c is equal to 4. This one's pretty basic. You should see that c is 4. Okay? So what this then does is we're going to take this equation here along with this c value here, and that will give us the final equation for y prime. So y prime is equal to 2x minus 3x squared, and now we have the c, so we can plug that in. So there is our y prime. Okay? All right, so next, let's just rewrite that so that we have that. So we have y prime is equal to 2x minus 3x squared plus 4. Okay, now that is the y prime. Let me rewrite one of the initial conditions that they gave us, that y of 0 is equal to 1. So now you have a y prime equation, and you want to find y according to the set of initial conditions that they gave you over here. So we're going to integrate the 2x minus 3x squared plus 4. Okay, that's the y prime. And remember, if we integrate y prime, we'll get y. So we're going to get y equals, and then we're going to integrate. So we should end up with x squared, let's see, minus x cubed plus 4x plus c. Okay, so that's going to be our setup for the equation for y. Now we're going to take the initial conditions that they gave us up here, and everywhere I see an x, I'm going to plug in 0, and everywhere I see a y, I'm going to plug in 1. So 1 equals 0 minus 0 plus 4 times 0 plus C, so therefore C is 1. Now, most of the time, by the way, just so you know, there's a little bit more involved than just plugging in 0. Your x values do tend to be something other than 0, so it'll involve a little bit more math. So now that you have that C is equal to 1, we're simply going to take our y equation and our C value, and we're going to write y equals x squared minus x cubed plus 4x, and now we know that C is 1. And there is our original equation. Okay, so now that you know how to find your C, tomorrow when you come into class, you're going to do a couple of AP review problems, and you will be finding the value of C. Good luck.